Hello, we are Team 10. I'm Lorraine Fuentes, Jorge Larrarte, and Jose Arraut, and today we are going to talk about the design of a power transmission system. This project involves the design of a power transmission system given certain parameters and specifications in order to provide for a working system and be able to apply it into a real-life application, while at the same time having environmental information that the system needs to withstand, as well as operational temperatures between several others. This table over here represents the data given as specifications. As you can see, it's supposed to transmit a maximum horsepower at the same time between maximum input and output shaft speeds. Also, the input and output direction must be the same, and the humidity levels are between 90 to 95%, and the operational room temperature varies between room temperature plus or minus 50 degrees. This application has as its purpose to be able to use in several industries, such as wind and energy, automotive industry, construction and mining, as well as agricultural. In order to understand this system better, it's important to know the concept. A power transmission system is the system in charge of the transmission of power from the source to the output, whatever that output is. The purpose is to increase the torque while reducing the input shaft speed so it can become the same as the output shaft speed. The most common sorts of implementations are for motor vehicles, and in our case, we're very interested in learning about wind turbines. This is the transmission system for a wind turbine, and it acts as a link between the blades and the generator. This is a more in-depth image in which the whole system can be seen. This over here is the generator, the blades, and the power transmission system.
Okay, after doing all the calculations, we decided to develop the idea to separate this gear transmission into parts. The first one, a pair gear of spur gears and a pair of bevel gears. Each shaft is going to have a pair of bearings. The first part of the project was selecting the gears. Following the admin procedure learning class, we calculate the factor of safety for each of the bearings, each of the spur gears, using the wear and bending and stress. As you can see, the factor of safety that we obtained are 1.24 and 1.14 for each one. I mean, kind of like that. And it's going to, it's greater than 1, so we're safe about that. The second part of the project was the shaft force analysis. This is going to follow the thinking procedure to select the bearings using the catalog, as the same with the gears. Each of the shaft we calculated and obtained that. A structural design, and this is the third part of the project, that is the shaft design. We evaluate the shaft using the, we evaluate the shaft. We evaluate the statical forces in the shaft and using the von Mises, and the cyclic forces using the Herbert method. Also, we developed the deflection analysis of the shaft, so we can see how much it's going to deflect and the slope that it's going to have. Also, the critical speed is very important to this one, and to see that if the input speed and the output speed is going to be okay for those shafts that we obtain. Now, Jose is going to talk about the case and support system.
Okay, thank you. Well, here we have the case and support system. This is our housing that we became. We decided to do a small one. As you can see right here, we have the shaft that is going to fix to this part, the second shaft right here, and the third shaft right there. The cost estimate, as you can see, well, the total cost that we became was with $746. That's a good reasonable price for our design. As you can see, in engineering, you need to have something good, really good, and at the same time cheap, with a good factor of safety. Here are the price of some of the components: the spur gears, the bevel gears, and the ball bearings. Also for the 3 different shafts. Of some of the maintenance of the gearbox, what we recommend is that we need to apply some cooling because of the humidity levels. As you was given on the parameters of the report of the project, the humidity is really high. So you need to, it's from 0.9 to 90% of humidity. So those colors are applied to prevent corrosion. Also, you need to do oil changes every 4 to 6 times, and you need to have a proper lubrication. Here, well, for the applications, the one that we became with was for the windmill of pumping water. As you can see here, we have a little video of our design. Here is the propeller where it's moving with the air, and then here's all the transmission system. We'll have the bevel gear right here and the spur gear right there. So actually the gears act as a link between the propeller and the pumping system. And for the conclusion of this project, we learned a lot. I mean, we actually put into practice all the material that we learned in class, even from Make Design 1 when we designed the shaft, and in this class Make Design 2 when we select the gears and the bearings. Thank you very much for your time. Thank you.
We did it, lo hicimos, o sea, en 6 minutos.
Ya, esa queda así.
No.
No.
You're
Dale
kidding,
otra.
you're
¿Tú sabes por qué?
Cierre.
Cierra, que estoy diciendo malas palabras y todo.
No importa.